Scenario: a 3 kilogram object is traveling at velocity 1I equals to 4 meters per second on a frictionless horizontal surface and collides head on and sticks to a 5 kilogram object that is initially at rest V2I equals to 0. Here are the image to give you that visualization. Question: what is the change in the total kinetic energy after the collision? Here, I'm only looking for a description of the change, not a calculation. We would say the answer: the kinetic energy decreases because in a perfectly inelastic collision, that's when the object sticks together, momentum is conserved, but kinetic energy is not. There is kinetic energy lost due to the need to stick the two objects together. Therefore, question: what is the value of the final velocity then? Well, the answer: this is the equation for conservation of momentum for a perfectly inelastic collision. Here I put the subscript of the 3 to represent the 3 kilogram object, the 5 to represent the 5 kilogram object. Okay, I plug in the values. Please notice that M5 V5I is equal to 0 because the object was initially at rest. This gets you 12, the other side gets you 8V divided over. You can get an approximate answer of 1.5 meters per second for the velocity final. So the question could be here: graph the scenario's velocity in meters per second as a function of time. So it starts at 3, then it drops down to the value of 1.5 there. So it drops because there is a increase in its mass because it sticks together. So that's how the velocity versus time graph would look like. That drop here comes from the addition of the mass sticking together.